So far in this course, you've learned how to retrieve data using the select statement, how to manipulate the data, and learned how batches work in T-SQL. As we go further, you need to know how to structure batches of T-SQL code that contain multiple modification statements and learn about batches that might encounter errors. In this module, you will learn about transactions. Transactions protect data by promising all or nothing behavior. They provide a mechanism for grouping a series of database changes into one logical operation. After changes are made to the database, these changes can be committed or cancelled as a single unit. You will also learn how to define transactions to control the behavior of batches of T-SQL statements submitted to Microsoft SQL Server and how to determine whether a runtime error has occurred after work has begun and whether the work needs to be undone or not. Let's first see what transactions are and how they are handled by the database engine. Earlier in this course, you learned that a batch was a collection of T-SQL statements sent to SQL Server as a unit for parsing, optimization, and execution. In this lesson, you will learn what a database transaction is, what the differences are between a batch and a transaction, and how transactions extend batches. Let's see what a transaction is. A transaction is a sequence of T-SQL statements performed in an all-or-nothing fashion by SQL Server. Transactions ensure that the properties of atomicity, consistency, isolation, and durability are followed so the data is correctly committed to the database. A transaction extends a batch from a unit submitted to the database engine to a unit of work performed by the database engine. Transactions are commonly created in two ways: auto-commit and explicit. Individual data modification statements like insert, update, and delete submitted separately from other commands are automatically wrapped in a transaction by SQL Server. Auto-commit mode is the default transaction management mode of SQL Server. These single-statement transactions are automatically committed when the statement succeeds or are automatically rolled back when the statement encounters a runtime error. Whereas an explicit transaction is one in which you explicitly define both the start and end of the transaction. This can be specified by using either SQL Server statements or database API functions. A SQL Server connection operates in auto-commit mode whenever this default mode has not been overridden by explicit transactions. User-initiated transactions are created through the use of transaction control language commands that begin, commit, or roll back the work based on user-issued code. TCL, or Transaction Control Language, is a subset of T-SQL. The primary characteristic of a transaction is that all activity within a transaction's boundaries must succeed or must all fail. No partial completion is permitted. User transactions are typically defined to encapsulate related operations together. For example, in the batch that you see here, it inserts data into two tables using two separate insert statements that are part of a single operation. When coding this query, the business rules might dictate that an order is complete only if the data was successfully inserted into both tables. But a runtime error in this batch might result in data being inserted into one table but not the other. To prevent this situation, you need to enclose both insert statements in a user-defined transaction. So when you enclose both the inserts in a transaction, you can undo the data insertion in the sales orders table if the insert statement into the sales order details table fails. You cannot achieve the same functionality using a simple batch. User transactions can be managed with T-SQL commands like begin, commit, and rollback. And while the transactions are active, the resources are managed by SQL Server on behalf of the transactions. These resources may include logs and entries in the transaction log to allow SQL Server to undo the changes made by the transaction if a rollback is required. So, now that we know what transactions are, let's see what the need for transactions is in T-SQL code. What would be so wrong if the first insert statement inserts the data into the orders table, but then there is no data that is inserted into the order details table? Like we discussed earlier in this course, batches of T-SQL statements provide a unit of code submitted to the server, but they do not include any logic for dealing with partial success when a runtime error occurs, even with the use of structured exception handling's try-catch blocks. Partial success of a batch may result in unacceptable results and simple error handling within a batch cannot repair this partial success. For example, in the batch that you see here, if there is a syntax or a name resolution error, the entire batch will error out and none of the code gets executed. But runtime errors only occur once the batch has been submitted, parsed, planned, compiled for execution. In this example, since it is a runtime error, we want to prevent execution of all the statements if one of the statements throws an error. So, in this example, if the first insert statement succeeds but the second insert statement fails, the new row in the sales orders table will persist even though the execution is branched to the catch block. But an order is said to be complete only if both the insert statements are successful. So to prevent partial success, you'll need to direct SQL Server to treat the batch as a transaction. Now let's see how to do that. Like we discussed earlier, runtime errors encountered during the execution of simple batches create the possibility of partial success. To address this, you need to add code to identify the batch as a transaction by placing the batch between begin transaction and commit transaction statements. Once the code is enclosed in a transaction, you'll also need to add error handling code to roll back the transaction if an error occurs. So if and when an error occurs, this error handling code will undo the partial changes made before the error occurred. Let's take a look at an example. In the query that you see here, within the try block, the insert statements are wrapped by begin transaction and commit transaction statements. This identifies both the insert statements as a single unit of work that must succeed or fail together. And if no runtime errors occur, the transaction is committed and the data is inserted into both the sales orders and the sales order details tables. But if an error occurs during the execution of the first insert statement, the execution branches to the catch block by passing the second insert statement. The rollback statement in the catch block terminates the transaction, releasing its resources, and none of the insert statements are completed successfully. And this is pretty much straightforward. But what if an error occurs during the execution of the second insert statement? If that happens, the execution is branched to the catch block, and since the first insert statement completed successfully and added rows to the sales orders table, the rollback statement is used to undo the successful insert. Now let's see an example that uses a transaction and without a transaction and see what the differences are. Let's open a new query, and I'm going to paste a query that is similar to the one that we just saw. And as you can see, both the insert statements are enclosed in the try block, and we are using identity to gather the latest order ID that is inserted into the sales orders table. Let's execute this query. And as you can see, the latest order that is inserted into the sales orders and the sales order details table is 11085. Now let's see if we can retrieve the data using some simple selects. From sales orders, where order ID equals 11085, and select star from sales order details, where order ID equal to 11085. Let's select both these queries and click on execute. And as you can see, both the select statements were successful. Now let's change the product ID from 11 to 101. Let's first see if there is a product with the product ID 101. Select star from production.products, where product ID equals 101. Let's select this query and hit F5 to execute it. And as you can see, there is no product with that ID, which means that this insert statement will fail. Let's select this whole batch and click on execute. And as you can see, the second insert statement threw an error. Now let's see if there is an order in the order details table with the ID 11087 that has been just inserted in the sales orders table. Select both the queries and click on execute. which means that the batch was only partially successful. To avoid the partial success, we need to enclose both the insert statements, or the whole batch in this case, in a transaction. So to do that, let's use begin transaction, and after the second insert statement, use commit transaction, and in the catch block, let's say rollback transaction. Let's add a print statement after the first insert to show us that the first insert has been successfully completed. Insert into sales orders successful. Now let's select this whole transaction and click on Execute. When you go to the messages, it shows that the first insert has been successfully done and the new ID that is inserted is 11090. Let's see if we can find that order in the sales orders and the sales order details table. 9090. Let's select both these statements and click on Execute. This shows that since we enclosed both the insert statements in a transaction, even though the first insert has been successfully done, since the second insert failed, the first insert has been rolled back. So far in this module, you've learned what a transaction is, what the differences between transactions and batches are, and how transactions extend batches. In the next lesson, you will learn how to control transactions using begin, commit, rollback transaction statements, and how to use exact abort to automatically roll back failed T-SQL statements.